We are asked to find the inverse of this exponential function and then graph the inverse. So you could see this is a growth function because the base is greater than 1, and there is no flip over the horizontal asymptote. The horizontal asymptote would be plus 5. But we are not asked to graph the original function. Rather, we are asked to graph the inverse. So the steps to find the inverse of this or any function is first to replace f of x with y as our first step. And then we are going to switch the x and the y variable. And the third step would be to solve for y. So in order to solve for y, which is now in the exponent, we're going to have to take the log of both sides. And here's the emphasis of this video. It's how to take the log of both sides. So the first thing we want to do is move the minus 5 to the other side. And we are now ready to take the log of both sides. Now, one way to do it would be to just take the log base 10, otherwise known simply as the log of both sides. So let's see where that takes us. Here's the left side of the equation, and now we're going to take the regular log base 10 of the right side of the equation. So the principles of logs allow us to bring the exponent in the front, and we're going to have now y times the log of 3 on the right side of the equation, and that then will allow us to divide both sides by the log of 3. And just do some moving around here. Apologize for this delay. And we're going to have this log of 3 over here in the denominator on the left side. And then we're going to replace y with the inverse label, which would be inverse of x. So folks, this would be our inverse right here. That is a satisfactory answer to find the inverse. But the problem is, in part 2, we're asked to graph this. So it is difficult to graph something like this. So in this scenario, we can do the reverse of the change of base formula. So recall, the change of base formula says that if we have log to the base b of an argument a, we can rewrite that as log of a over log of b. And we could choose any base we want in this scenario. Well, folks, we can do the opposite. If we're given this, we could do the change of base formula in reverse. So that's what we're going to do here. So we're going to take this fraction and change it back to this format. So that's going to give us the log of x minus 5 as the argument, and the base is going to be 3. So the argument in the denominator becomes the base, and the argument in the numerator becomes the argument in the condensed version. So now this is our inverse, and we can proceed to graph this function. Folks, let's go back to the original exponential function here in red, and let's find the inverse in a much more efficient way than I did a few moments ago. Recall, a few moments ago I took the regular log base 10 of both sides. But watch how much easier this is. I've done the first two steps. I've replaced f of x with y, and then we've switched the x and y variable. Our goal now is to solve for y, which is up in the exponent. So rather than take the natural log, or the log to the base 10, we're going to be a little more strategic. First, we are going to subtract 5 from both sides. And here, we're going to take the log to the base 3 of both sides. And let's see where that takes us. Over here on the right side, because the base of the log matches the base in the argument, these cancel out and you're left with the exponent. That brings us directly to this spot right here. And that is what we ended up with here when we did the reverse change of base formula. Folks, this is a much more efficient way to go. So the key is recognizing at this stage that you have the base on the opposite side of 3, and you utilize that base when you take the log of both sides. Let's now proceed with graphing this now inverse function. And we can see it's a logarithmic function. We have a plus sign here and a plus sign here. So the intuition of this graph is that it is eventually, its end behavior is going to go where the x value is positive and the y value is positive, and that is the first quadrant. Recall, this is true only if this base is an integer as opposed to a fraction. For example, if instead we had 1/3 here, if we had 1/3 here as the base, like so, then this end behavior of this log function would still go to the positive in the x, but it would go towards the opposite of what that sign indicates. So the y value would tend towards a negative. So if that base was 1/3, this graph's end behavior would go where x is positive and y is negative, and indeed that would be the fourth quadrant. But let's go ahead and go back to the original base, which was 3, and recognize that this graph is eventually going to head towards the first quadrant. Okay, the way I like to do these graphs is I like to take the argument and I'd like to set it to 3 things. To 0, that's going to give us our vertical asymptote. Then I set it to 1, and then I set it to the base. And in this case, the base is 3. Then we're going to solve for x. So in this case, x equals 5, positive 5. That is our vertical asymptote. So let's go ahead and get our graph going. Sorry. Here's our vertical asymptote right here at x equals positive 5. So folks, I already know that this graph is going to hug that vertical asymptote and head towards quadrant 1. But let's go ahead and get some points to prove it. Okay, first, we set the argument equal to 1 and we solve for x. And we're going to get x equals positive 6. We set it equal to the base and we're going to get x equals positive 8. Now we build a table using those two x values. Let's have x equals 6 and x equals 8. Now, to find the y values, we're going to do f of 6 and f of 8. Let me go ahead and make some room. Watch how easy it makes the math when you use this technique. Okay, so first I'm going to do f of 6 here. I should say inverse f of 6. So that's going to be log to the base 3 of 6 minus 5. That equals log to the base 3 of 1. And anytime you have 1 in the argument, this whole log is going to go to 0. Let me prove that to you. If you have log to the base 3 of 1 equals question mark, if you use the whirlybird technique, we're going to have 3 to the question mark equals 1. That is going to go evaluate to 0. So our y value on our first point is 0. Now we're going to do f to the negative 1 of 8 to get our second y value. We're going to have log to the base 3 of 8 minus 5. Okay, all we're doing, folks, is taking this green 8 and plugging that in for x. We're going to get log base 3 of 3 to the first power. Whenever the base of the log matches the base of the argument, this cancels out. You're left with the exponent. So now we're going to have 2 points. We're going to have 6 comma 0, and we're going to have 8 comma 1, and our graph, as promised, heads towards the first quadrant. In this next problem, we are again asked to find the inverse and then graph it. This is an exponential function with a horizontal asymptote at positive 1. It's a growth function, so the graph would move away from the horizontal asymptote as we move left to right. But again, we are not asked to graph this. To get the inverse, we first replace f of x with y. Step 2 is to reverse x and y. So we're going to have x equals 3y minus 3 plus 1. We're going to subtract 1 on both sides, and we're going to get 3 to the y minus 3. Okay, here's where we make our decision. Because that base is 3, we're going to take the log to the base 3 of both sides. That makes our math easier on this side. Whenever the base of the log matches the base of the argument, you can cancel those out. We're going to get y minus 3 equal to this side of the equation, and then we're simply going to add 3 to both sides. And this, folks, is our inverse. We're going to replace y with the inverse symbol, like so. Let's go back a few steps in this problem where we're finding the inverse of this red exponential function. We replaced f of x with y, we switched the y and the x, and now we're in the process of solving for y. So it was at this stage a few moments ago where we took the regular log to the base, we took the log to the base 3 of both sides, and that made our math very easy. But what if you didn't think of that and you just took the regular log of both sides? Because of the principles of log, we could bring this over, and we would then have the log of x minus 1 equals y minus 3 times log of 3, and then we would divide both sides by log of 3. Again, that's to the base 10, and these would cancel out, and we would be left with the log up here in white, x minus 1 over log of 3, and y minus 3 on this side. Then we would bring this minus 3 to the opposite side, and we would end up with something like this. Okay, because in part 2 we are asked to graph this, this is not a graph-friendly expression. So again, you could use the reverse of the change of base formula and change this fraction to this expression. This argument goes there, and this argument becomes the argument like so. This is in a much more friendly format in order to graph this now inverse function. Now that we have our inverse function, let's go ahead and graph it. As we expect, the inverse of the original exponential function is indeed a log function, and we see that our sign located inside the parentheses of the argument along with the x is positive, as is the sign out here. Because that base is a integer as opposed to a fraction, we're going to follow the designation in terms of end behavior. It's going to tend towards the quadrant where the x is positive and the y is positive, and that will be indeed the first quadrant. First thing we do is we set the argument to three things. We set it equal to 0. That's going to give us our vertical asymptote. In this case, it's going to be x equals positive 1. That is our vertical asymptote. Then we're going to set the argument equal to 1, and we're going to solve for x. When we do that, we get x equals positive 2. And third and final thing we're going to do is set this equal to the base, which is 3, and we're going to end up with x equals positive 4. Folks, we're going to go ahead and place our vertical asymptote at x equals positive 1, like so. And we already know, based on our intuition, this graph is going to do something like that. Let's go ahead and plot these points using these x values. Here's our table. Here's x equals positive 2. In order to get that y value, we're going to plug this 2 into the equation and evaluate the y. If we plug 2 into x inside the argument, we're going to get down here in green the log to the base 3 of 2 minus 1 plus 3. This is going to evaluate to 1 in the argument. Whenever you have 1 in the argument, that goes to 0, so we're left with a y value of positive 3. Next, we're going to place x equals positive 4 into that same now inverse equation. We're going to get log to the base 3 of 4 minus 1 plus 3. This argument is going to be 3. So we're going to have log base 3 with an argument of 3 to the first power. These cancel out. You're left with 1, and 1 plus 3 is positive 4. Our vertical asymptote was at x equals positive 1. We're now going to graph 2, 3 and 4, 4. This graph is going to hug the vertical asymptote and head towards the first quadrant, just as we predicted. Folks, I went ahead and used Desmos to graph this inverse function, and you could see here there is a vertical asymptote at x equals 1, and you do have the points 2, 3, 4, 4, which is exactly what we had here, 2, 3, 4, 4, and positive 1 as the vertical asymptote and heading towards the first quadrant.